Okay, so this focus thing doesn't always work very well, but hopefully it is focusing on the board, as long as I stay near the board. Okay, so vertical motion model. So yesterday, or not yesterday, but over the weekend, on Friday, I explained to you how to solve word problems, quadratics, right? When you're dealing with area of a rectangle, right? Area of a rectangle.
27.
Yes, 27. Today we're going to talk about word problems using what's called the vertical motion model. And this is the actual formula for the vertical motion model. Make sure that's written down in your notes. We're going to talk about each part of it, and then we're going to do a quick example and see how you can use this. Very, very fun and exciting formula once you understand what it does. This will tell you how long it takes a penny to fall off the Empire State Building. It'll tell you how long something's in the air when you shoot an arrow out of your bow, right? It'll tell you lots of things, right? This is a lot of very, very useful piece of information or piece of useful formula. So first of all, we got to look at the anatomy of this formula, right? The anatomy. Make sure I can see I'm on the board. Anatomy of the formula. H. That is the height at any given time. The height, sorry, I got to write in capitals. The height at any given time. Now, what do you think is time in this equation?
T.
Right. So T is the time. And, whoops, I wrote in small lowercase. Time, though, is in seconds.
Oh, here's lowercase.
It's in seconds, okay? Right? And then V stands for initial vertical velocity. And I'm going to explain all these things to you in a second. And S, that's an S. It's just, I write it weird because I don't want it to look like a 5, right? S is the starting height. H-E-I-G-H-T.
Can we just make the S like put a line
Yes.
through it so it looks like a dollar sign?
However you want to do it, it's fine.
Go.
So let's talk about it. H is the height at any given time. So think about it. First of all, is this going to be a happy face or a sad face parabola?
Happy face.
Oh,
sad face.
Sad face, because the A is negative 16. It's a negative number, right? It's got to be a sad face, which makes sense. Every time I toss something in the air, it comes back down again. It makes a beautiful, perfect parabola, right? Can you see that on the thing? Okay, great. So it's going to make a beautiful parabola, right? And so if this is my graph, let's say there's my parabola, right?
Actually, really good.
Right? Not bad, right? So I know that at time 1, the height is going to be here. At time 2, 2 seconds, it's going to be here. At time 3 and time 4. At time 4, it's going to max out right there. And at time, whatever. And then it's going to eventually come down. So at any given time, I could plug this in, put 1 in here, and I'd find my height at 1 second. I could plug 2 in here and find my height at 2 seconds, right? So that's what H is.
Can we do 2 seconds?
Well, wait, I haven't finished. I got to do a real problem in order to do that. But so time, T is time in seconds, so that's pretty obvious. 1 second, 2 seconds, 3 seconds, right? V is initial vertical velocity. What is velocity, first of all?
It's the speed.
It's like speed, right? So vertical means upward movement, right? So now think about it. Sometimes you jump straight up and down. Sometimes you jump sideways, right? But still, there is a vertical motion, right? Going upward. So if there is a vertical motion, then that would be it. That would be your vertical initial velocity. What if I took a rock, a marker, and I threw it up? there would be initial vertical velocity, right? It's vertically going upward before it comes down. Do you agree with me?
Yeah, parabolas don't work.
What if I, and so it's going to be a positive vertical velocity. What if I threw it? Oops. That was my good marker. That was my good marker.
Oh, Gary.
Ben,
What? Oh my god.
anybody see my marker?
It's rolled over there, Gary.
Where?
It's my foot. I know that.
Can somebody find it for me?
Oh, it's under the camera stand.
Under where?
Camera.
Oh, right here. Got it.
Gary, do
Okay.
parabolas work in
Lovely,
space?
lovely, lovely film. I love this video. Great. Okay, so it's going to be a
Throwing markers.
So if I throw it vertically downward, it's a actual negative vertical velocity. Do you see what I'm saying? If I throw it upward, it's a positive. If I throw it downward, it's a negative vertical velocity. What if I drop it? When I don't do anything, I just drop it. I don't want to drop it this time.
Drop it again.
If I drop it,
before.
Does it? I did it again. But if I just drop it, right? Was there any vertical velocity?
Yeah.
It just, I dropped it. So vertical velocity is 0 if I just drop it. Does that make sense?
It had
You get that?
inertial velocity.
Okay. S is the initial, S is the starting height.
So like if you started.
So if I started on the ground, if I kicked a soccer ball from the ground, my starting height would be at 0, 0. Does that make sense?
Yes.
If I'm shooting an arrow and my arm, the arrow is about 4 feet off the ground, my starting height would be up here at 4. Does that make sense? Right? So, I'm going to give you an example. Oh yeah, take a picture. Take a picture. Quick, quick, quick.
Mike, you got a new
Get that
phone.
out. Get it ready. Take that picture fast. We're running out of time. I've got 2 minutes to do a problem. Okay, good.
Yeah, he's no longer with the C. He's got the 6S. and now
So
got the
guys, I'm sorry
6S.
I'm rushing through this. But really focus now. Really focus. So the kangaroo. A kangaroo. So here's my problem. Okay, a kangaroo jumps from the ground into the air. You guys should be writing this down, not talking. Into the air. A kangaroo jumps from the ground into the air with an initial vertical velocity of, we'll just keep it simple, 16 feet per second. Okay? By the way, I didn't tell you, but the height is always in feet with this formula. This is a feet per second formula. This is feet per second. It's not meters per second, it's feet per second, okay? Okay, how long was she, it's a she, by the way, in the air? It's very important that it's a girl.
Of course.
Very important, right? Just kidding. All right. So a kangaroo jumps from the ground into the air with an initial vertical velocity of 16 feet per second. How long was she in the air? So I'll wait, so let me know when you're all done writing it down. And then you're just gonna have to stay like 2 minutes after,
So
sorry.
is it always 16t squared or negative 16?
Yeah, just write down the problem, you'll see, yes. This is always the same.
Oh, okay.
Yeah. So, okay, so we're gonna write our formula. H is equal to negative 16. Now we don't know the time, do we? That's what they asked us to find. How long was, they're asking us to find time. So negative 16t squared plus what? 16t, right? My vertical velocity is 16t. Now what's my starting height?
1, 0.
0. She started from the ground. That's 0, right? So I'm not going to say anything else. That's it. All right, now it says, how long was she in the air? Well, what am I looking for? Am I looking for the time that she's up here or the time that she's down here? That time that she hits the ground, right? right? So this is my time, right? And this is my height, right? My height. So I want to know when the height, the h, is 0, what is t? Does that make sense? When the height is 0, I'll be on the ground. Does that make sense? Therefore, I'm being asked to find the zeros, right? When h, which is normally a y, is 0, let's do it. I'm going to put my 0 on the other side, though. I'm going to say it equals 0. Negative 16 t squared plus 16t equals 0. Well, that's interesting. What's my c? I don't have a c, right? My c is 0. Therefore, factor out the greatest common factor. So I'm going to keep it simple. I'm not going to bother with the negative. It doesn't matter, to be honest with you. I'll just do 16t, parenthesis, I've got negative t plus 1 equals 0. So either if a times b equals 0, then either a equals 0 or b equals 0. So I've got 16t equals 0, right? Which means t would have to equal 0. T equals 0. Or negative t is equal to, negative t plus 1 equals 0, right? So I'm going to add t to both sides, right? If I add t, look at this. 1 is equal to t. So either t equals 0 or t equals 1, right? So think about it. He jumped at 0 time, right?
That was she, Gary.
She jumped, thank you. She jumped at time 0, but she landed again at time 1. So it's just 1 second. So that's my answer. Does it make sense?
Yeah.
They're really pretty easy. As long as you understand the formula, you plug it in, find the zeros. There's, I think, actually all of these, there is no C's on all of these. So it's just like this one, okay? So just practice them like this, and you'll have no problem with them. Make sense? So your final answer says,
She was in the air for 1 second.
yeah, she was.
It's important, Gary. It's a she.
She was in air for 1 second.
I'm just gonna put for 1 second.
Right?
Okay.
Good. Perfect. All right, that's it.
Okay,
Let's
so
try.